Jan Bosch is a professor of software engineering, director of Software Center, a collaboration between 5 universities and 16 companies to accelerate digitalization. We consider digitalization as consisting of software, data, and artificial intelligence. For me, what I see is that many of the contemporary AI approaches have a centralized approach. They collect the data and bring it all to a central location, train everything in a central location, and then distribute the trained models towards the edge again. And I think that that's a approach that will become increasingly unappealing for a number of reasons. One, the amount of data that you and computational infrastructure that you have to build up in a central location is extremely expensive. I know of companies that are spending hundreds of millions of Swedish crowns a year just to maintain the infrastructure. And on the other hand, it's very wasteful because I have thousands, if not millions of devices out on the edge that often have excess computational capacity and could and should be used for taking much more responsibility for the different AI tasks on the edge. And there is one more thing, if you allow me to add that, which is that if you look at the trends, you can see that the amount of computational power available at the edge is growing much faster than the communication bandwidth between the edge and central location. So we will over time have more and more computational power on the edge, and the amount of communication bandwidth that we have available will actually not improve at all the same rate. I believe that the current approach of a product leaving the field, leaving the factory, and then being the best, and then slowly deteriorating over time, is a product model of the past. If we now look at our mobile phones, if we look at our computers, if we look at other equipment, that those products are receiving new software updates, sometimes even new electronics updates on a continuous basis. And the idea is that we see a situation where the products that I'm using are getting better every day that I use them. I can get better in different ways. I can push new software towards the devices in the field, but the other is that I can allow devices at the edge to actually experiment and learn from their own behavior. And then we get to forms of reinforcement learning or even federated learning, where different devices can exchange learnings with each other so that a fleet of devices or a population of devices can collectively become better at their job over time. And I think that that is the situation where I would like to see things going, is that the product, the moment you receive it, it's the worst it will ever be during its entire life. And from that point on, it will get better every day you use it. It depends on which aspect that you're looking at. I mean, Tesla is, I think, a good example of an automotive company that is pushing out software on a very frequent basis and has now also started to offer products, electronics upgrades in the product to the market as well. If we look specifically about reinforcement learning and federated learning, there we are working with companies in the software center. I don't want to mention their names, but that is currently in the prototyping and experimentation stage. We haven't yet reached the stage where we can industrialize that, but I do know of other deployments, for instance, in the software as a service world, where people are employing these kinds of techniques of runtime optimization of models. People often present machine learning as a binary situation. Either you train at the edge or you train in a central location. And I believe that in an industrialized scenario, what you will do is you will start by training a model in a central location up to a certain level of performance. Once you know that the performance is good enough to avoid catastrophic failure in the field, you can deploy the model at devices on the edge. And then the model can, either through federated learning, where all devices exchange learnings, or through localized optimization, become better and improve its performance over time in its physical location where it is based or where it is kept. So I think what we're going to see is a mix of where we start at the central location, push to the edge, and then have the final optimization occurring on the edge. Traditionally, every product that left the factory has exactly the same performance, independent of where it is used and by whom it is used. If you look even in the case of federated learning, the idea still is that every device in a population will have exactly the same model, because all these devices are exchanging learnings with each other and everyone is basically staying on the same baseline. I believe that since different devices are placed in very different contexts, you should allow for ways in which those devices can optimize themselves for the specific context in which they operate. This can be location. If you have a car in northern Sweden, it mostly sees reindeers and trees. If you have a car in central Rome, it will mostly see people and old buildings. So I think that these two cars should be allowed to optimize their models based on the context in which they operate, similar to users. I mean, different people have different driving preferences, so a self-driving car should adjust to your preferences rather than follow the factory settings. So if you talk about mass customization, it is how do we add solutions to products that allow the products to adjust themselves to the context, to the user in which that is using the system, or the context in which they operate. In the cloud, the cost of storage and the cost of computing is often much less than what you have on the edge, because on the edge, power constraints, storage constraints, computational chip cost constraints, etc. Because you have to replicate any design decision you take over all the devices, you can find situations where the cloud can store large amounts of data cheaper than what you could do on the edge. Also, it is more easy to operate from one central location and control a large population of devices. The disadvantages I already alluded to in one of the earlier answers to one of your questions is that when you have a large set of devices, the amount of data and the amount of training that you would have to do centrally can become prohibitively expensive. And you are actually wasting a lot of the computational resources and storage resources that are available on the edge. So, and that's where I believe that the edge actually has huge advantages. I mean, imagine a situation where you talk about an automotive company that is trying to do object recognition. I can have either one large central data set with one central trained model, or I can use 100 or 200 or 500,000 cars on the road that are all through federated learning jointly developing the best object recognition algorithm. Yeah, there is no way that you can replicate that level of resources that you have on the edge in a central location without making it prohibitively expensive. So I think it's that balance that we're looking for. But what I want to stress once again, it isn't either or. I think it is start in the cloud with a limited data set and a reasonably performing model, then go to the edge and drive the optimization of the model on the edge. What's the guy's name? Said prediction is hard, especially about the future. But the fact is that every device that costs more than a few pennies will be connected to the internet, will be generating data, will be sensing its context, will want to respond to what is happening in its context in a non-algorithmic, but rather in a smarter way. So if you ask me what I hope the world will be like, is not 1984 and everyone is continuously monitored in a very negative way. Instead, I hope for a world where we live in a space where the devices around us add value to our lives on a continuous basis and actually learn to respond to our preferences and needs in such a way that the devices improve our quality of life in ways that we can currently not even imagine. That's at least what I'm hoping for, and I believe will be the future that we're going to be seeing. If we look at the edge, computational resources available on the edge are constantly increasing. We see that the cost of sensors and small actuators is actually dropping, following Moore's law. We see that, I know that this is controversial, but energy usage with the adoption of solar will make the availability of energy on the edge actually easier and easier. I think that also the whole notion of having to be physically connected will become less of a concern. So, I mean, there are a number of futurologists are predicting that electricity will be free in about 10 years. If you follow the price line, it will basically be free. So if you look at a situation where edge devices have high computational resources and storage resources, are able to sense the world, are able to interact with the world, don't need to be connected with a cable to power or the internet, but can use wireless communication and local energy storage, we're moving towards a very different world. And if you allow me, we have been swinging back and forth between a centralized architecture in computing and a decentralized architecture in computing. We started the world with mainframes, and then from the mainframes, we all swung over to PCs, and everyone had their own PC. And then we swung back all the way to cloud computing, and everything was centralized again. And what I believe is that we're now starting the wave where everything is starting to decentralize again, because that is a natural way of evolution that you can see in technology. And there will be other centralization waves. There will be things that are hard to solve on the edge. But by and large, I believe that the major trend is that things are moving from currently being overly centralized to a much more decentralized approach. And that is a lot of functionality will live on the edge. What I know, and of course, I think Ekkono is a beautiful company, and I'm really impressed with the technology advances that the company has made. The focus on not only inference on the edge, but also training on the edge and managing as much of the machine learning process on the edge is, I believe, one of the strong points of Ekkono. And I believe that that's important because it is such a beautiful complement to the centralized cloud-based approach that many companies have in place. And where I think that Ekkono and its customers will really have to focus on is, how do we think about linking the existing centralized approaches with the capabilities that Ekkono offers on the edge? Where are the best business opportunities in that space? That's where I see that Ekkono has a great starting point, and I think also still a bit of exploration to do with the customers, because there are use cases where you can do the full training locally. I mean, anomaly detection is a good example. You first learn what normal is, and then you detect anomalies. But there are also cases where you do need the centralized approach to complement what you're doing on the edge. And I think that that part is something where, on the one hand, Ekkono has a great starting point, and on the other hand, the company would benefit from, at least from my understanding, thinking a little bit more deeply about the interaction between how do we integrate cloud and edge.